Welcome to Alphanumeric Tricks. In this video, we are going to see Unit 1 Differential Calculus. Under that, we are going to see the topic Representation of a Function. This is the syllabus under Anna University Engineering Mathematics 1. Now we will see what is a representation or how you can represent a function. And last video we have seen that the basics about the introductions about differential calculus. The link is available in the description box. If you want, please have a look on it. Now we will see what is a function now. Suppose you are giving some input x is given to something and a machine or something like that. You can take it. After some operations you can get the output f of x, or you can say that y is equal to f of x. So here in this function is manipulated. In this function some manipulations are going on. After that your input, we get the output, and you get one input, which is, suppose you are giving one input and exactly one output is obtained here. Okay, why we call this function y is equal to f of x here, or f of x is equal to y. Here f is a function and x is the input, and we get the output as y. Okay, so that's why we call this y is equal to f of x. Function of input is equal to the output, or otherwise f of x is equal to y. We can simply denote like this. So consider this example. Y is equal to 3x and y squared is equal to x. Using this example, we can easily understand what is a function and what is not a function. Okay, suppose you are giving x is equal to 1. What about y is equal to 3 output? When you suppose you are giving output as x is equal to 1, the input x is equal to 1, the output y will be equal to 3. So y is equal to 3 into 1, you have a 3. Suppose you are giving input as x is equal to 2, y is equal to 3 into 2 is 6. So you get the output as 6. Suppose we plot this in a mapping. Okay, so consider the set D and E. In this, so the rule in the here, the function or operation for f is 3x. Okay, the rule or operation for 3x is the function here is 3x. So depending upon this 3x only, your input gives the output. So when you're giving x is equal to 1 as the input, the output will be equal to y is equal to 3, substituting x is equal to 1 here. In the same way, when you're substituting x is equal to 2, here y will be equal to 6. So here each element is exactly mapped into the only one element as the output. Okay, that's why this is called a function. Consider this term y squared is equal to x. You can this term be written as y is equal to plus or minus square root of x, because taking square root we get y is equal to plus or minus root x. Suppose you are giving x is equal to 1. What about y will be equal to plus or minus root 1? Here the value for x is equal to 1 is the single input we are giving, but we get two outputs. Y is equal to minus 1 and minus of root 1, sorry, y minus root 1 and plus root 1. So this is not possible. In function, suppose you are giving one input, you should get exactly only one output. So this is not a function. So we can define a function as this function consists of set of inputs, set of outputs, and a rule or methods for assigning each input to exactly one output. This is the function. Okay, this consists of set of inputs and a set of outputs and a rule. Here what is the rule, on which according to that a rule only we get the output, assigning each input to exactly only one output. This is the function. Now we will see what is a domain. Set of all inputs is called a domain, and here x is equal to 1 and x is equal to 2 are the domain, and the set of outputs is called the range. Y is 3 and 6 are the range for this. Okay, so range is the set of outputs. Now consider this figure or mapping. x is equal, that is in the set, in this set we have the elements -1, -2, -3, -4. According to the rule, this is mapped into 1, 2, 3, 4. That is, each -1 is mapped into 1, -2 is mapped into 2, -3 is mapped into 3, -4 is mapped into 4. Did you guess which rule is applied here? Yes, f is equal to modulus of x. When here this is the x and this is y or f of x, you can see that. So when you are applying f, is the rule here is modulus of x. So modulus of 1 is 1 and modulus of 2 is 2, modulus of 3 is 3 and modulus of 4 is 4. And here each element, that is each input is assigned to exactly only one output. So, and here that's why it is called a function, and the domain here is -1, -2, -3 and -4, and range here is 1, 2, 3 and 4. Okay, this is the mapping of the function example. And now we will see in the set notation. Consider f is a mapping from set A to set B, and here A is called the set that is domain of f, and B is called the codomain of the function f. Okay, now consider the elements. Suppose x belong to the set A and y belong to the set B, and you can write this to be y is equal to f of x. Okay, so here y is equal to f of x. X belong to A and y belong to the set B. Suppose the elements are y is taken in B and x is in A, then you can write y is equal to f of x. That is, each element of A is mapped into the element in B. Then you can write y is equal to f of x here, and then this y is called the image of x under f. Y is called image of x under f. Okay, and now we will see what is a range. Set of all images. Okay, set of all images of all the elements of A. All the set of all images of all the elements of A. Here this is the image. So set of all images of A, set of all images of all the elements of A under f is called the range of the function, and is denoted by f of A. So f of A is equal to set of all f of x such that x belong to A and f of A is contained in B. Here this f of A must be contained in B. This is the range of the function, and here you can consider this f of -2 is equal to 2. Any example we consider from this, f of -2 is equal to 2, and what you call it 2? 2 is called the image of -2 under f. Okay, and how will you do this -2? -2 is called the pre-image of 2 under f. Okay, this is that is 2 is image of -2 under f, -2 is pre-image of 2 under f. Okay, this you can you should remember. Now we will see what are the different ways we can represent a function. We can represent a function in 4 ways. One is numerically by tables, another one is algebraically by formulas, and verbally, and last one is geometrically by graphs. What is numerically by tables? That is, suppose depending upon the value, that is, you consider some function. Here y is equal to model x, we are considering same term. So when you are substituting the inputs -1, y is equal to modulus of x. So x is equal to -1 when you are substituting, y is equal to +1. X is equal to -2 here, y is equal to +2, because absolute value we are taking. So x is equal to -3, y is equal to 3. X is equal to -4, y is equal to 4. So we write all the inputs and the outputs in a table format. That is numerical values only we are writing. That's why this is also a representation of the one way of representing the function. Another way is algebraically by formulas. Circumference of a circle we are considering. What is the circumference of a circle formula? C is equal to 2 pi r. Here, what is dependent variable and independent variable? How will you change the values here? Depending upon the radius, your circumference vary. So, what is your dependent variable then? And what is your independent variable? Yes, C is that is, C depends on the value of the radius. That's why C is called the dependent variable and R is called the independent variable. Okay, and also exactly one value of C, that is one value of C for each value of R. Okay, for each values of R, that is one radius, we get one circumference. One different radius, different radiuses, we can get different surfaces. So only one input is given, we get only one output. Input is radius, output is circumference. Only one thing is given. That's why this is the function. Okay, so we can algebraically by formulas also you can represent a function. Next one is verbally. Verbally in a sentence form we can write it. The rule assigned to each day of the year, the temperature at noon at Delhi airports. Okay, so we are considering the temperature at noon in the Delhi airport of each day of the year we are considering. That is the some rule is assigned here. So this is the way we can verbally represent the function. Next we can represent the function by graphs. Okay, in algebra when you represent the function by graphs, it is visually it will give more clarity to understand the function. Okay, so we can represent this by using graphs. We can easily understand the function. So graph of the function f, we can have domain 1 2 3, domain of the terms to be taken as 1 2 3, that is we are giving the input 1 2 3, and rule f of x is 3 minus x. So that is we are giving in the real number. So the values, that is the domain and the codomain. When you're substituting x is equal to 1 2 3, we suppose x is equal to 1 as the input, then here the value output we get is 3 minus 1, which is 2. So we have to write output as 2. Suppose you are giving x is equal to 2 as the input, the output y will be r f of x will be equal to 3 minus 2 is 1. So write it here. And then suppose when you are giving x is equal to 3 as the input, then f output y will be equal to 3 minus 3 0. So this is the coordinate points we are considering: 1 comma 2, 2 comma 1, and then 3 comma 0. These are the coordinates points we are considering, and using this coordinates points we take this the domain, that is a set of all inputs are taken as domain and outputs is taken as the range. So using that is a domain, and using domain and range we plot these pairs in the xy plane. Okay, so graph consists of the points x comma f of x for all x in the domain. Okay, so we have to take the domain is in the x-axis and range we take it to be in the y-axis. Okay, so here we consider this domain 1 2 3 is taken here and range is 0 1 2 3, and we have to plot the coordinate points 1 comma 2, that is when x is equal to 1 and the value of y will be equal to 2. So this is the value we have, and then when x is equal to 2, the value of y will be equal to 1, the output will be equal to 1. When you suppose you are giving input as 3, the output will be equal to 0. So this is the point 3 comma 0. Join all the points so you get a straight line. Okay, and this is the this is the one way of representing the function, and here the real value for the real numbers are the domain. Here the domain and range are the real numbers we are considering. Okay, and then here we have considered the another way another graph. Here in the consider this parabola y squared is equal to x. In this parabola, here we are having points, and this parabola we consider this, and here in this line graph, suppose you draw the line here. When you move this line from here, point these points in this straight line, the point of intersection we get it only one point. Okay, the straight line is touched at this line. When you're moving this line from this point to this point here, this from this here to here, then the line touches the line. This line touches here at only one point. Okay, so we get that is each input we get the exactly only one output. We can conclude like this. Whereas in this So this is a graph. Each input we get the exactly only one output. So this is a graph. And consider this. What about this? Suppose in this line, you move this line from in this parabola, this point to this. In 0 there is no problem. Here also there is no problem because there is no terms there. Only point only one touches only in the x-axis. Suppose whereas here in this parabola, when you're moving this line from here points to this point, then here we have the line touches at the parabola in 2 points. So when you're giving the input, we get 2 outputs for this. So this is using this we can conclude that when you're giving input x, and you get 2 outputs for this because the line touches the curve at 2 points. So that's why this is not the graph. Okay, this is not the graph. This is the way we can conclude the graph. Okay, definition of the graph we will see. What is the graph of a function definition? Graph of a function is a drawing. This is a drawing that represents the all input output functions. Okay, input output pairs, we consider this is the representation of this. And in other words, the graph of f consists of the points x, y in the coordinate plane. Okay, the points consist of the point that is all points x, y in the coordinate plane such that y is equal to f of x we are having, and x is the domain of f. Now we will see some more definitions. Explicit function. Suppose x and y be related, and suppose you can write y is equal to some function of x. Okay, y is equal to some function of x. You are writing like this. That is your left hand side you have one y alone, and right hand side is a function of x alone. So you can say that this is the explicit function. What is implicit function? It is not possible to write like this. Okay, x and y are related, and y cannot be written like this. So suppose y and we can say that y is called the implicit function like this. We can't split this. X cube plus y cube minus 3xy is equal to 0. In this equation, we can't split x terms together and y terms together, and such type of function is called the implicit function. What is a real valued function? A function whose range is a set of all real numbers. Okay, range is set of all real numbers, then that function is called the real valued function. Range is always the set of all real numbers, then only we can say that it is a real valued function. If it is not a real number, then we can't say that it is not a real valued function. For example, let us here x is the x3 f of x we consider, and also if the range of the real valued function is not explicitly defined, then you take the whole x-axis is the that is the entire layer line R. Its whole x-axis can be taken as the range. Now using some examples, we define what is a real valued function clearly. Consider this mapping. Set A and set B is there. Set A is having A, B, C, D 4 elements, and each element is mapped into exactly one element, and one element is extras there. That is nothing wrong in that. So this is the function, because only thing is each input you have only one output. That is the thing you have to consider. So each element is mapped into exactly only one element. So it is a function. And what about real valued function? Is this one, the range here, the range is a 1, 2 and 3, 4. The range is a real numbers, then only we can say that it is a real valued function. So here the range here is 1, 2 and 3, 4. This is a real number. So we can conclude that this is which is set of real numbers. So we can conclude that it is a real valued function. Consider this example. Here this mapping. A, B, C, D, set A, set B, A, B, C, D, some rule, depending upon some rule, if A is mapped into 1, B is mapped into 3, C is mapped into 2, and D is mapped into T, and 4 is left out here. But here, each element is mapped into exactly one element in the set B. Okay, each element of A is mapped into exactly one element of B, then you can say that it is a function. Okay, what about real valued function? What about the domain range here? Range here 1, 2, 3 and T. 4 is not mapped, not an output, so this is not a range, leave it. So 1, 2, 3 and T. This is a real number, so what we doesn't know about T, so this is not a real number. So set of real numbers, so we can say that this is not a real valued function. That's all for this video. If you have any doubts in this, please provide in the comment section. Thanks for your time and thanks for watching. Keep watching our YouTube channel Alpha Numeric Tricks for more videos. Thank you.